So hello everybody. So we've got a nice problem here today. Namely, if we know that there's a container holding 100 liters of a saline solution in which there's initially 0.5 kilograms of dissolved salt, and if a stream of another saline solution with a concentration of C is equal to 0.05 kilograms per liter is allowed to flow into the container at a rate of 8 liters per minute, when will the concentration of the salt in the solution become equal to 0.02 kilograms per liter? Okay, so we want to know how the mass of the salt and how the volume of the solution in the container change. So for our first step, what we're going to do is find out just how exactly the volume of the solution is changing. So the volume that's going into the container is equal to 8 liters per minute. So that means that volume prime is equal to 8. Volume prime can be rewritten as dV over dt. That's the derivative of volume with respect to time, and it's equal to 8. So from here we get a separable differential equation which states that dV is equal to 8 times dt. Once we integrate both sides, we'll see that V is equal to 8 times t plus some constant c. Let's go ahead and find that constant from the initial condition. It says that the container is initially holding 100 liters of a solution, so that means that when t is equal to 0, the volume is equal to 100. Plugging that into our equation, we get that 100 is equal to 8 times 0 plus c, and of course this is 0, so c must be equal to 100. So V is equal to 8 times t plus 100. Okay, that's the equation by which the change of volume of the saline solution in the container changes. Okay, now let's go ahead and do the same thing for mass. So how much mass are we exactly getting into how much mass of salt are we exactly getting into the container? So if we go ahead and multiply C and V prime of the inlet flow, we'll get 0.05 kilograms per liter and times 8 liters per minute. The liter and liter cancel out, and we'll get that this is equal to 8 times 0.05, which is simply 0.4 kilograms per minute. And of course, this is equal to m prime. Okay, so m prime is equal to 0.4 or dm over dt is equal to 0.4 or dm is equal to 0.4 dt. I keep saying point, but it's a comma. Whatever. I like to use the comma as a separator. So once we integrate both sides, we'll get that m is equal to 0.4t plus c. Now again, let's solve this problem by using the initial conditions. It says that initially the saline solution contains 0.5 kilograms of salt. So that means that when t is equal to 0, the mass is equal to 0.5 kilograms. Okay, once we plug in this initial condition into our equation, we get that 0.5 is equal to 0.4 times 0 plus c, and this of course is 0. So from here it follows that c is equal to 0.5. Or in other words, the mass must be equal to 0.4 times t plus 0.5. Okay, now that we know how the mass of the salt is changing and how the volume of the saline solution is changing, we can get how the concentration is changing with respect to time. So the concentration at any given moment is equal to the mass of the salt at that moment over the volume of the solution at that moment. So this is equal to 0.4t plus 0.5 and over 8t plus 100. Now we want to find out at exactly which moment the concentration of this solution will become 0.02 kilograms per liter. So that's 0.02. From here, we get that 0.4t plus 0.5 is equal to 8 times 0.02, which is 0.16 t plus 100 times 0.02 is just equal to 2. Or, in other words, we get that time times 0.4 minus 0.16, 0.4 minus 0.16 is equal to 2 minus 0.5. Okay, and so t must be equal to 2 minus 0.5, which is 1.5, over 0.4 minus 0.16, and 0.4 minus 0.16 is equal to 0.24. So time, and remember the time is strictly in minutes here, must be equal to 6.25 minutes. So in 6.25 minutes, the solution will have a concentration of 0.02 kilograms per liter. Okay, and let's just go ahead and write the unit, minutes. Okay, so that's our final answer to this problem. I hope you enjoyed the video. If so, leave a thumbs up and subscribe. I'll see you in the next one.